Hey, everybody. So this one, we're going to talk a little bit more about histograms. I did one where I built one by hand, and then I used Google Sheets to build one. I just want to talk about histograms a little bit. We want to start getting used to looking at them and interpreting them. One of the big reasons we do this, histograms, right, is to look for patterns or to explain something to somebody, and looking at a sheet full of data doesn't tell us very much, right? It's hard to understand just a table full of numbers. But when we look at histograms or some of the statistics we'll look at later, where we summarize data with simpler, a smaller set of numbers like a frequency table or something you're familiar with like an average, or pictures, which can really help us understand what's going on even if we don't have all the details, right? You're always playing this game between full detail and understanding, right? Sometimes too many details get in the way, and we need to step back and see what's happening. And histograms are a really good way to do that. So I'm just going to take a look through a few histograms, some I found online, some I've created, and just kind of talk about some of the things we might see from these histograms. So let me go ahead and share some of my screens with you. Okay, so here, let's focus on the top one for now. This is Major League Baseball salaries in 2005. So like all histograms, we're looking at frequencies along this vertical axis, and then we're looking at salary data along the horizontal. In this case, these buckets, these classes, right? This first column is all the salaries between 0 and 100 and 125 million, right? So I think something becomes very obvious when we look at this, this first column, right? Not that sorry, did I say 125 million? 1.25 million, pardon me. Not that that's not a lot of money, but we can see the vast majority of baseball players are making in this column. And I know if you look deeper into the data, it's more in like the $300,000, $400,000, and $500,000 mark. And the insane baseball salaries that we hear about, the things up in the tens of millions of dollars and so on, are really only representing these very small numbers, right? You can barely even see that there's a couple of salaries up here, closing in on $20 million, right? And so that's the rarity, not what's common, right? It's much more common for still a great salary that any of us would be happy to be making, but not the sort of image I think a lot of us have of what baseball players might be making. Let's look at the distribution below. This is data. This again is a histogram. This is data that I collected from my in-person classes over the last few years. One of the things we would have been able to do had we met together was I like to give you guys things like coins and dice and have you flip and roll them so we can create some data. So here are, I have had 432 students roll a 6-sided die. Right? So it has the numbers 1 through 6 on it. And so this first column represents anybody who rolled a 1, a 2, a 3, 4, 5, and 6. And without looking at the details, it's pretty clear that what our expectations probably are. I think most of us expect that dice rolling, that when you roll a die, you have an equal chance of getting any of the numbers, and that looks to be the case, right? It's not perfectly even, but we see that we're getting about the same amount of each die. So that's one of those examples of telling a story by looking at this, even if we don't see the details. We see this even distribution of data. All right, let's take a look at another one. How about, let's see. Here is an interesting one I found. I think this is, yes, this is the one we're looking at. So we're not gonna spend a long time looking at this, but here is a picture of 143 students at the University of Connecticut. If you look closely, these placards in front are heights. This is anybody between 5'0" and 5'1", 5'1" and 5'2", 5'2" and 5'3", and so on, right? And so they're sort of making a living histogram here, where the frequency is just how many people are standing in that row. So we can see that the most people are right. This tallest column is the one between 5'6" and 5'7". You might also notice, if you look closely, it appears that they have divided this group of people into men and women, and have the women wearing white and the men wearing black. And if you kind of squint and just look at the black colors, you see kind of its own histogram, which has a slightly higher peak, right? So let me try to highlight this. There's an interesting thing happening here. So, right, if you look under this red line, right, that's kind of the shape of just the men. Now, I can't do the same thing with the women because they're stacked on top of the men in this way, but if you imagine sliding this group of women down and this group down and this group down, you'd see a kind of a similar shape just shifted over a bit, right? I think we can imagine that. And that is an example that on average, we see, there's a couple of things going on here, but on average, we see that women are a bit shorter than men. So that's why that peak, everyone's heights, the women's heights are a bit smaller. We also notice these are both in kind of a similar shape. I'm not going to go deep into this idea, but this shape, right? So I'll try to draw it as clear as I can, right? Is something we call the bell curve or the normal curve. And we're going to be talking quite a bit about that in the future. It's this idea, right? If you have an average, most people are close to the average with fewer people farther away, right? So if you look, it looks like the men's average is maybe somewhere in this area, and lots of the men are there. Very few are much shorter or much taller, right? So people tend to cluster around the average, and then fewer of them further away. All right, let's look at another one. Oh, while we're talking about height, let's do this. Let's take a look at another bit of height data. Let's see. So this is pretty similar to what I just showed you. This is a histogram. So I found data that a professor at UC Davis had with about 200 students of mixed gender. And we kind of see that same, oops, sorry, there, I hope you're still looking at the screen. It's a similar idea to the one I was just showing you, this idea that we kind of have two different peaks, where the average woman peaks and where the average man peaks. And we see a similar idea here, that this histogram seems to have a little bit of a peak here and a separate peak here, and then, right, now I'm just drawing a rough idea of the shape of this graph, of course, but I think that's relatively clear that that's happening, something like that. Maybe there's a third peak happening here too. It's hard to say. We would need a little more data to see exactly what's going on. This is in centimeters, but we see a similar idea that somewhere around 164 centimeters, we see one group of students clustered, and we see a second clustered up around 175. And so maybe that can also be explained by the typical differences we see in, shouldn't say typical, maybe the average differences we see across genders. All right, let's keep moving. What's next? How about, let's look at this one. Here is an article from the New York Times. This is a histogram, although instead of doing frequency across the side, they've chosen to do relative frequency. So if you notice, across this axis here, it's percentages, right? So instead of counting up how many meals, it's how many meals divided by the total number of meals. And what they're showing us is how many meals have what range of calories, right? So it looks like each of these ranges is about 50. So maybe this is the meals with 0 to 50. Maybe there's 0 to 50, 50 to 100, 1 to 150, 150 up to 200, something like that, right? And we see that most of our meals, or most of the meals at, this is at Chipotle, are clustered around, right? It looks like a little, just a little bit below 1,000, right? Maybe around 900, we're seeing this highest group of meals, right? The researchers noted that there's a second peak that appears over here, right? That they think is a bump from chips and guacamole. They don't really have an explanation for this one. I'd be curious. I don't know enough about Chipotle to try to make a guess at what that might be, but there's probably some reason why we see this extra peak over there, right? So again, we get this nice visual display instead of a list of, right? You could present the same data in full detail with a name of a meal and how many calories. And if you looked at this data, it would be a huge spreadsheet of just names and numbers. It would be very difficult to glance at it and tell what we can tell here, that most meals are between around 900 calories. There's very few up above 2,000 and very few below about 400, right? We see very few down here. And so this graph gives us quite a bit of information at a glance, right? This article has a couple other things, similar histograms for sodium and saturated fat, right? And we can see very different kinds of pictures here. One of the things we'll do later in the quarter is try to compute some numbers that tell us a bit about how data is spread out. But just looking at this picture, notice milligrams of sodium per order. This looks like it's much more tightly packed together versus this data here, which is kind of spread out across the whole graph, right? So there's more variability over here. It looks like at a glance. We'd have to do a little bit of computation to make a better assumption of that, or a better assessment of that. All right, a couple more I wanted to look at. All right, here's one that I found some data. This is some COVID data from yesterday, right? No, from today. So this was made in Europe, so it was collected, what was during the middle of the night for us, I believe. I'll post a link to this, and I have a link to the source where I got the data from. But they have data of new cases per country on the 16th. And I turned that data into, I wanted to normalize it for population, right? So that countries with larger populations obviously tended to have higher numbers of new cases, but instead what I did was do number of new cases per million people and created this histogram. And we see that the majority of the countries are down in this column here, under 8. Right, looks like there's 65 of the countries, and then we have very few countries sort of spread out in this middle ground. And then notice the bucket sizes change a little bit. Most of these buckets are about 8 units wide, right, or 8 cases per million wide. But then it jumps from 80 to 591, right? If you look at this list, there's this group of countries near the top. 591 new cases down to about 101 new cases that are all very high, and then all of a sudden our numbers of new cases starts to drop off pretty significantly. And so it just kind of groups all of these together. If we kept going with bucket sizes of 8 to start at 0, because there's a couple countries that had 0, there's several countries that had 0, to go all the way up to 600, we would lose a lot of information. This graph would become huge and wide, and we'd have huge gaps, right? And so we're clustered some of this information together in this last bit of data. And then if you wanted to investigate that further, you could go look at those in particular, right? And these top 15 or so, or 8 or so pieces of data are a lot easier to look at. on their own. All right, so I think I had one more to show us. Oh, yeah, there it is. Okay, one more to show us. This is also some COVID data. This is from the Lancet, and it's showing, well, I'll look afterwards to see the dates. I'll link this as well. But this is showing a histogram of age ranges, right? So if we look down here, right, these age ranges apply to both graphs, right? 1 to 4, 5 to 9, 10 to 14, and so on. And it's showing the number of cases. And this one is actually showing a little double histogram and indicating which of these cases ended at the time of making this graph where the patient had deceased, right? And so you can see some pretty good information from this, right? We see the distribution is clustered in the middle. We see the highest amounts in the what, 40-ish range, but we see the deaths cluster up in the much higher range, right, up in the 70s and 80s, right? So this is how we can get a lot of the information we have, right? A lot of the stuff that we know about this, people are doing analysis by looking at charts like this. So anyways, I just wanted to make a quick, just start chatting about frequency distributions and histograms. I'm going to be giving you an assignment soon that's going to help us dig a little further into how do we interpret these things, because as I've said in the past, we're going to look at these. If you're studying statistics, you're going to look at a lot of histograms. They're a really good and common way to examine information. All right, that's it for this one.